In the earlier sessions, we discussed about versatile nature of carbon. Now we will discuss about the chemical properties of carbon compounds. At the end of this session you will be able to understand about chemical properties of carbon compounds and its types. Combustion, oxidation, addition reaction, and substitution reaction. Let us move on to chemical properties of carbon compounds. The most common carbon compounds are hydrocarbons, that is, alkanes, alkenes, and alkynes. Since most of the fuels we use are either carbon or its compounds, there are 4 types of chemical properties. They are combustion, oxidation, addition reaction, and substitution reaction. Let us discuss one by one in detail. Combustion, the process of burning of a carbon compound in air to give carbon dioxide, water, heat, and light is known as combustion. Combustion is also called burning. Most of the carbon compounds burn in air to produce lot of heat. For example, alkanes burn in air to produce lot of heat, due to which alkanes are excellent fuels. Let us take an example of the combustion of an alkane called methane. When methane, that is, natural gas, burns in a sufficient supply of air, then carbon dioxide, water vapor, and a lot of heat are also produced. Chemical equation for combustion is CH4, that is, methane, natural gas, plus 2O2, that is, oxygen, on combustion, gives CO2, that is, carbon dioxide, plus 2H2O, that is, water, plus heat, plus light. Let us note that, because natural gas produces a lot of heat on burning, it is used as a fuel in homes, transport, and in industries. The saturated hydrocarbons, that is, alkanes, generally give clean flame, whereas the unsaturated hydrocarbons, that is, alkenes and alkynes, give sooty flame. Here a CNG, that is, compressed natural gas, cylinder fitted in the boot of a car, which does not cause much air pollution. Why do substances burn with, or, without a flame? All the gaseous fuels burn with a flame, but only those solid and liquid fuels which vaporize on heating, that is, to form a gas, then burn with a flame. Example, cooking gas, LPG, is a gaseous fuel, which burns with a flame directly, but wax and kerosene oil are solid, or liquid fuels, which vaporize on heating, and hence burn with a flame. Burn with a flame. Flames are of 2 types, blue flame, and yellow flame. Now, let us see about blue flame. Blue flame. If the oxygen supplied, or air supply, is sufficient, then the fuels burn completely, producing a blue flame. For example, the gas stove has holes for air to mix properly with cooking gas. The cooking gas gets sufficient oxygen from the air, and hence, burns with a blue flame. Now, let us see about yellow flame. Yellow flame. If the oxygen supplied is insufficient, then the fuel burns incompletely, and producing mainly a yellow flame. Example, candle flame. The yellow color of flame is caused by the glow of hot, unburnt carbon particles produced, due to the incomplete combustion of fuel. When a candle is lighted, the wax melts, rises of the wick, and get converted into vapors. In a candle there is no provision for proper mixing of oxygen for burning wax vapors, which leads to incomplete combustion of wax. The unburnt solid carbon particles rise in flame, get heated and glow to give yellowish light. This makes the candle flame yellow, and luminous. Burn without a flame. The solid, or liquid fuel, which do not vaporize on heating, but burn without producing a flame. Example, coal and charcoal burns in an angeeti without producing a flame. Angeeti is a place in a room, which is used to keep warm with the help of fire. Let us discuss the formation of coal and petroleum. Formation of coal and petroleum. A fuel is a material that has energy stored in it. When a fuel is burnt, the energy is released mainly as heat. Most of the common fuels are either free carbon or carbon compounds. For example, coal, coke, and charcoal contain free carbon, whereas kerosene, petrol, LPG, and natural gas are all carbon compounds. How coal was formed? Coal is formed by the decomposition of large land plants and trees buried under the earth millions of years ago. How petroleum was formed? Petroleum was formed by the decomposition of the remains of extremely small plants and animals buried under the sea millions of years ago.